Okay, so recall that a chord is a segment with endpoints on the circle. And here we have a chord, endpoints on the circle, and it divides the circle into a major arc here in blue and a minor arc here in red. And that's true for every chord, unless it's a diameter, which it cuts the circle then into two semicircles, which we have here in blue and red. So what does that mean for us? In the same circle, here we have one circle and we have two congruent chords, which means since these chords are congruent, it means these arcs are going to be congruent as well. So let's go to color. So if AB is congruent to CD, then arc AB is congruent to arc CD. And this would also be true if the circles were congruent. If we had separate circles that were congruent and we had congruent chords, then we would have congruent arcs as well, which we're going to see in our example right here. Here we have circle P and circle Q. And as we can see right here, the radius for each circle is congruent. Here we have segment GF, which is congruent to segment JK. And the measure of arc JK equals 80 degrees. And since GF is congruent to JK, the measure of arc GF is also going to equal 80 degrees. Because the circles are congruent, the chords are congruent, therefore the arcs are congruent. Let's look at another example. Here we have circle D, and segment AB is congruent to segment BC. So if the measure of arc AB equals 110 degrees, what does the measure of arc BC equal? It's going to be, 110 degrees as well. So let's get rid of this and say, so if the measure of arc AC equals 150 degrees, what is the measure of arc BC? Well, AC is this one right here. And because, let me get that color here. AB is congruent to segment BC, to chord BC. Then arc AB is congruent to arc BC. And we know this is 150. So 360 minus 150 equals 210. 210 divided by 2, because I've got this one and this one, which are congruent, was 105. So the measure of arc BC equals 105. And we are